Dr. Russell Humphreys is a retired physicist who researches, speaks, and writes about creation science from his home office in Chattanooga. Previously, he did so for the Institute of Creation Research in San Diego and Creation Ministries International in Atlanta. In 1963, he received his BS in physics from Duke University. And in 1972, he received a PhD in physics from Louisiana State University. In 2001, he retired from Sandia National Laboratories in Albuquerque, New Mexico, after working there for 22 years as a physicist doing nuclear physics and geoscience research. Before that, he did high voltage research at General Electric. He has published dozens of professional articles, received 3 U.S. patents, 2 Industrial Research Magazine IR 100 awards, and several Sandia National Laboratory awards for excellence. Although raised as an atheist, he received Jesus Christ as his personal Savior in 1969 as a grad student in physics. A few years later, strong scientific evidence convinced him that the alleged billion-year geologic ages are fictional and that instead God created the world about 6,000 years ago. His main research interest is the age of the world, including magnetic fields in the solar system, which we'll talk about today, salt in the ocean, nuclear decay dating, and cosmology. He has published many technical articles in creationist scientific journals, is a board member of the Creation Research Society, and is an internationally known seminar speaker. He is the author of the popular book on creationist cosmology, Starlight and Time, a co-author of Radioisotopes and the Age of the Earth, and a recent book, Earth's Mysterious Magnetism, which we have on sale on our book table, by the way, and that of other celestial orbs. So would you please give a warm North Carolina welcome for Dr. Russell Humphreys.
Thank you. Thank you for making allowance that I'm from Duke. So I appreciate your interest, and I'm just happy about this conference. I think it's a great one. So I want to tell you about God's big magnets in the sky, including the Earth's own magnetic field. And this is a subject I've been researching since the early 80s. Now this is actually something fairly shocking. I'm going to be pointing to the left screen with my pointer. God used water to make magnetic fields in the cosmos. This is something surprising, but I'll show you what led me to this idea and what it results in scientifically. But you don't think of water as being a magnetic sort of material. But this is just the bottom line of the whole talk. It explains the magnetic fields of planets, stars, and galaxies. And then we jump into what the magnetic fields come from. Now, you know water has 2 hydrogen atoms in it. So here's the water molecule, and the blue stuff is the electrons around the molecule. And this is the oxygen nucleus, and these are the 2 hydrogen nuclei. They're spinning balls of charge, protons, and we know from laboratory measurements that these make a small magnetic field. It's about 1/1000th of the field that the electrons make, but the electrons in a water molecule are all matched in pairs, so that they cancel each other out. And the nucleus of the oxygen atom, the protons are matched in pairs, and the neutrons are also matched in pairs. So there's no magnetism from the oxygen nucleus, but there's no matching for the hydrogen nuclei. Each of these hydrogen nuclei can spin in any direction, point in any direction with respect to each other and with respect to other molecules. So you don't normally think of this stuff as being magnetic. However, the water molecule would be slightly magnetic if you lined up these protons so that they spin in the same direction. Now, so the field depends on their orientation. And so now I'm going to get to something new that even people who study the Bible haven't noticed very much. But it looks like God formed the earth from created water, that he created water first and then turned it to other substances. And this is the verse that I got that strange idea from. The earth was formed out of water and by means of water. 2 Peter chapter 3, verse 5. I was studying that verse back in the early 80s, and it suddenly struck me that if God wanted the earth to have a magnetic field, he could do it really easy by making all the water that he made later converted to the solid earth, making all that water in that first instant have protons that all point in the same direction. So now, also know that, or would think that God would conserve mass. You've heard of conservation of matter and energy. If the normal way he would do it is take the mass, the mass he wanted the earth to be, and make the same mass or amount of material of water. So I had a pretty good idea that the mass of that ball of water there was the same as the earth is now. And we know the mass of water molecules, so you divide the one by the other, and you get about 2 times 10 to the 50th water molecules, or 2 with 50 zeros after it. So physicists use zeros like carpenters use nails. We keep big buckets of nails, of zeros handy, and just grab them. Okay, well, this is 50 zeros. That's a fair amount. But we know the magnetic strength of each proton. So just multiply the magnetic strength of one proton by 2 to the 50th power, and you get a magnetic field that works out. So if all the hydrogen nuclei are aligned, then you get a fairly substantial magnetic field. That's the number, 7.9 Gauss. To calibrate you, the Earth's magnetic field right now is only about half a Gauss. That's the magnetic field right here in this room from the Earth. So this is about 16 times greater. And that turns out to be pretty handy, considering what else happened to the magnetic field between creation and now. I'll get to explaining that. Now, right after their creation, these water molecules, if God let normal physics happen, all these water molecules would bounce into each other, just normal thermal motion, bang, bang. And each collision would disorient a spin or two. So the molecules would collide, disorient the spins, and this would start an electric current in the water. So let me explain what that's all about. But within seconds, this process would happen. So there are some normal laws of electricity and magnetism. This would happen within seconds, would make an electric current within the ball of water, which at high pressures and higher temperatures than normal, down inside this big ball, you would have an electric current able to flow. And the laws of electricity and magnetism I'm talking about are called Lenz's law and Faraday's law. But as each molecule or each proton got disoriented and tried to reduce the field strength a little, the laws of electricity and magnetism would induce, that's the word, a little bit of current in the core or in the interior. So that's the electric current. It would flow from east to west around in a circle around the axis. And it turns out that those laws of electricity and magnetism would give you enough, it would try to preserve the field that was already there at the same value, and that would make a current of 250 billion amperes. Just for comparison, today the current in the Earth's core is about 6 billion amperes. So the field is preserved by this action, and then when God transformed the water into the solid earth by the beginning of the third day of creation, you see that in Genesis chapter 1. So it would be now a solid planet with a core, an electrically conductive core, like we have now, and a solid shell of rock, which the German word for shell is mantle, so it's called the mantle. And transforming to the solid earth would preserve this magnetic field yet one more time. So there's the current now in the core, and the total field would stay the same. Now, what happens then? Well, the electric current in the core would run down like a flywheel runs down due to friction. So this would represent the electrons in the core, in the metallic core, going round and round. But the core is not a perfect electrical conductor. It has resistance. So the resistance would, just like friction on a flywheel, would, reduce the electric current steadily. So here you have the electric current meeting resistance. And so the current would just run down like a big flywheel. So here's a plot of electric current in the core versus time in years, and here's 6,000 years, here's now, and here's creation. And the current would run down from 250 billion amperes down to 6 billion amperes today, and that gives you a half-life of about 1,100 years. And then the normal laws of electricity and magnetism would give you about that half-life. Now, half-life is nothing to be scared of. It's just the time it takes to diminish by a factor of 2. So if we start with 250 billion amperes, wait 1,100 years, it would be 125 billion amperes, and so on down to today. So a little, say about 5.5 half-lives between creation and now, if the biblical time scale of 6,000 years is correct. And that's what all this is about, really. Is the biblical time scale correct? So now, this is as close to an equation as I'm going to get. So those of you who have fear of algebra or worse, fear not. This is as bad as it's going to get. So this half-life up here is proportional to, or it's equal to a constant, physics constant, times the electrical conductivity of that core times the radius of the core squared. So if the radius is big, you will have a longer half-life. So a planet like Jupiter, which is really big, you would expect to have a much longer half-life, which means its magnetic field would decay more slowly than the Earth's magnetic field does. Now, the Earth's magnetic field has been observed by secular scientists for nearly 2 centuries now, and it's fading fast. So this is data, actual observed data, and I'm taking up in the year 1900, going to the year 2010, and this is the strength of the source of the main part of the Earth's magnetic field. So you don't need to worry about the units or anything, but the strength of that source is decreasing on the average year by year according to that red line, And in detail, it looks like we have a little sinusoidal, little jiggle of about a 60-year period up and down from that. And I think I understand the reason for that, but overall, it fits this law of decay, the red line, very, very well. So, so this is observed. This is not theory. Let's see, and the half-life today for what's observed is the 1117 years. Okay, now, as a result of this, I got to thinking, okay, if God made the magnetic field of the Earth this way, what about planetary magnetic fields, the other magnetic fields you see in the solar system? So I wrote it up in a creationist journal, but the bottom line is that this creation theory I wrote up made some predictions. I said if my theory is true, then we should see certain things that we haven't had a chance to observe yet in the solar system. So in 1984, I did this creation of planetary magnetic fields. So that's in the Creation Research Society Quarterly. If that's one of the 4 creationist technical journals that are peer-reviewed, and this one was peer-reviewed. And you can go to creationresearch.org and find the Society website, and you will find this in the publicly listed articles deep down in the bottom of the pile. And in that article I made 5 different predictions about things that hadn't yet been measured in the solar system. So some of the space probes had visited parts of the solar system, but there were other parts that the space probes did not visit. So one of those places was the planet Uranus. The theory said that Uranus should have a strong field. I actually gave numbers for this and said within a factor of 3 above or below that, order of magnitude is the physics term, the field should be this strong, and gave a number. And I just did that by taking the mass of the planet Uranus and figuring how many water molecules were there to begin with and adding things up, and then making a guess. They had some guesses available then as to how big the core of Uranus was, so I could use that simple law to get the half-life of the decay of the field of Uranus, and then I could get it pretty well. If so, the planet Uranus should have thus and such a field, I said. Now for Uranus, the other side, I should tell you a bit about the other view. The people who believe in a billion-year-old solar system have devised various theories to try to explain how the magnetic fields of planets, like smaller planets particularly, like the Earth, could maintain their field for billions of years. So they're called the dynamo theories, and the first one came out in 1919. Sir Joseph Larmor speculated, mostly he didn't really have a good theory at that time, that somehow the motions of the fluids in these conducting cores would be such that they would maintain their field through the billions of years in spite of losses by resistance. And dynamo is the English word for electric generator, and he was English, so they're called the dynamo theories. And we've had a lot of different variations on the dynamo theory theme since then, and none of them really works. They all reach sort of a hand-waving stage, and they just don't work very well. And they've tried a lot of variations. The theories have gotten steadily more and more complicated. But they depend on motions in the fluid core of a planet, which are driven by heat. And the planet Uranus, astronomers can observe how much heat is coming from that planet's surface. This would be heat coming from the deep interior over billions of years, they would figure. And Uranus doesn't have much heat. So they said, oh, well, there can't be a dynamo there, or if so, it's a very little one. So they assumed that the field would be a figure about 100,000 times smaller than what my theory was predicting. So this is a good test. So that was one prediction. Then Neptune should have a strong field, and I gave a number for it. Neptune is kind of a sister planet to Uranus. They're about the same size. And so my theory was saying they should have a strong field. Their theory was saying that since Neptune and Uranus are sister planets, we guess that the field at Neptune should also be low. And then Mars presently has no magnetic field at all, no global magnetic field. But my theory was saying that about the time the planet was created and new rocks were being formed, that its field would be pretty strong, just from my origins theory. So those rocks in the crust of Mars should be strongly magnetized by Mars's magnetic field. So my theory was saying if they ever can manage to get samples of Mars crust, I was thinking maybe some astronauts would have to bring back those samples. They should prove to be strongly magnetized. And then Mercury's field should decay fast. So Mercury was visited in 1974 or 1975 by the Mariner 10 space probe, and to their surprise they found that Mercury had a small but significant amount of magnetic field. It was about 1% of the strength of the Earth's magnetic field today, and they had thought there would be no field. I'll explain more about that, but they were surprised that they said, okay, it has a field, but it's been around here for billions of years, so that field shouldn't change rapidly, so future space probes should not measure much different. My theory, however, knowing that Mercury's field, or thinking that Mercury's field had decayed from a large value 6,000 years ago to this field that they measured in 1974, says that future space probes should detect a relatively fast decay. For 30 years it would be about 5%, my theory was saying. So then the fifth thing was that Mercury's field, my theory was saying, was once much stronger than it is now, and when its crustal rocks were being formed, they should also be strongly magnetized. Okay, how did we do? Well, back in '86, 2 years after my article, the planet Uranus agreed with the predicted field. This is Voyager 2, a picture of it at Uranus. And the creation theory was saying on the order of 1 with 24 zeros after it, ampere meter squared. That's the unit that measures the strength of the source of the field. And so I gave this number. On the order of can mean just plus or minus a factor of 3. And Voyager measured something right in the middle of that range, or close to the top of the range, I guess. 3 times 10 to the 24th ampere meters squared. And remember, the other side was saying a factor of 100,000 less than that. So the dynamo prediction was smaller. So score now is Humphreys' crazy theory 1, dynamo 0. Okay, 1989, the same space probe, Voyager 2, got out to Neptune, and Neptune agrees with the field that my theory predicted. So similar number, and Voyager measured a similar number, 1.5 times 10 to the 24th. But the dynamo theorists cheated. They said, well, since Uranus turned out to have a strong field, and Neptune is a sister planet, then Neptune should also have a strong field. So we'll give them credit for, a sort of prediction there. So now the score is Humphreys crazy theory 2, dynamo theorist 1. Now, this is in an Institute for Creation Research little pamphlet called the Impact Series, and it came out in 1979, and the title is Beyond Neptune. So you can go to icr.org and go to their Impact archive and search for that, Beyond Neptune. It has both Neptune and Uranus results. So now in 2001, this was a surprise to me. Mars' crust is strongly magnetized. I had predicted that, but I didn't think they'd be able to measure it until they got some astronauts down to take some samples of the crust. But this thing called the Mars Global Orbiter orbited close over the surface of Mars and plotted out this map of magnetic field strengths of the crust of Mars. Remember, the overall field of Mars is 0. So any little magnetism places you see on there are undoubtedly from the crust of Mars. And so there's different polarities. The red means magnetic lines of force coming out of the board, and the blue means magnetic lines of force going into the board. And these numbers are rather strong numbers. They're about 10 times stronger than the magnetizations that we see in the Earth's ocean bed, in the ocean floor. You may have heard of the magnetic stripes that parallel the mid-ocean ridges. They are about 10 times less intense than these stripes here. So now this is a plot of this is a map. So here is 0 degrees longitude all the way around back again to 360 degrees longitude. And this is latitude up at the North Pole, 90 degrees, the equator at 0, and South Pole at minus 90 degrees. So you see down near the South Pole, there are these strong bands of alternating reversed and normal strength things. That was something I hadn't figured on in 1984, that in addition to the known reversals of the Earth's magnetic field, that Mars, apparently when these rocks were being formed, was experiencing reversals of the direction of its magnetic field also. A lot of you probably hadn't heard that the Earth reversed its magnetic field, but the rock evidence says that while the fossil layers were being laid down, and we think that was during the 1 year Noah was aboard the Ark, about 4,500 years ago, during that 1 year, the rocks say there were about 100 reversals of the Earth's magnetic field. So that's one every 2 or 3 days. So if Noah had looked closely at his compass on the Ark, he would have been able to see the magnetic field slowly swinging around. And we have recorded, by the way, evidence in the rocks that these reversals did take place in a matter of days and not in a matter of millions of years, as the dynamo theory was thinking. So anyhow, I didn't predict the reversals, but the strengths very much agree with what my theory was saying the original strength of Mars' magnetic field should be. I would say the other side didn't even have this kind of prediction at all. So it's Humphreys 3, them 2, no, them 1, okay. So it fits that 1984 prediction. And then in 2012, the planet Mercury contrasts the creation and the dynamo theories. This is the Messenger space probe, which flew very low, especially over the northern pole, the northern volcanic plains of Mercury, and measured magnetic fields there. So this is the second visit to Mercury since 1974, 2012, 1974. And the dynamo theory, you may remember me saying this, before a space probe visited Mercury said, 0 field. Okay, oops, Mariner in 74 said, oops, it's got 1% of Earth's field. So they modified tried to modify their theories. And then the dynamo in 2008. So the dynamo theory was saying before 2008, well, okay, we measured a small field at Mercury, but it shouldn't change much because these things take millions and hundreds of millions of years to change, according to our theory. So they would say no detectable decay before it was first measured. 2008 is when Messenger made some flybys of Mercury, and then 2012 is when it finally settled down into this tight orbit around Mercury. So it really measured the magnetic field of Mercury quite well when it started orbiting. So before 2008, no decay. And creation 1984 was saying about 5% of decay. Messenger actually got close to 8% decay, 7.8%. That's an enormously fast change for a magnetic field of something as big as a planet. And there are signs that the dynamo theorists are not happy with this number, and so, but they aren't talking about it explicitly. I won't go into all the details, but they are not acknowledging this fact, but it's plain from the actual data. Now, by the way, I predicted 5%. This is close to 8%. There's a small knob on my theory that I can tweak that I didn't even think of tweaking in 1984 that could easily explain the additional 3% decay. Okay, the dynamo theory before 2012 was saying that the field on Mercury couldn't have been much greater than it is now. So they were not thinking of any strong magnetic field back in the past. The reason they think the magnetic field at Mercury is weak is because Mercury rotates very, very slowly, and it's an essential part of their theory to have rotation. I think Mercury has about an 88-day rotation period. That's pretty slow. So they weren't expecting any field to begin with. When they got one, they said it couldn't change. So that was their prediction. But in 1984, I was saying, well, it had a strong past field, and we know it's weak now, so it must have decayed pretty fast. But it had a strong past field, and there would be some evidence of this in its crustal rocks also, if they were created or made or formed shortly after creation, thousands of years ago. Then we should see evidence of that. And Messenger found that there was indeed a strong past field. Those northern crustal rocks were strongly magnetized by a strong field. And by the way, they're magnetized in the opposite direction to the direction of Mercury's present field. So Mercury has gone through at least one reversal of its magnetic field. It looks like this was a solar system-wide phenomenon. So, okay, I'm happy about all this. Let me just run through the predictions. Uranus has a strong field. Neptune, same. Mars has a strong crustal magnetization. Mercury's field decays fast, and Mercury's crust is magnetized. Okay, in the last decade or decade and a half, moons, asteroids, and meteorites also agree with the theory. By the way, my 1984 article discussed the moon's magnetic field, our moon, and right now it has no global field either. But it turns out that the rocks the astronauts brought back show a strong field at the beginning and then a rapid decay of the field. The moon's core is small, so the half-life of its decay should be about 100 years. But other moons in the solar system, such as Jupiter's, some of Jupiter's moons, clearly agree with the theory, and they don't agree very well with the dynamo view. So this is the satellite of Jupiter called Io. It's a volcanic moon. And this is the space probe Galileo going by, and that's big old Jupiter in the background. And Jupiter's moon Ganymede has a strong field. There are some asteroids that we've sent space probes to, and they are strongly magnetized. They apparently have a lot of iron in them, and that iron was strongly magnetized. And then meteorites, it turns out, many of the meteorites they find were magnetized also some time ago before they fell, and then and up to nearly, some of them were in fields as strong as the Earth's field is now. So, I'm happy with all that too. The sun has a really big in extent magnetic field and a fairly strong one. And this is a picture of the sun at sunspot minimum, when the field is really uncomplicated. It's just regular lines of force going in and coming back down. And but the sun's magnetic field reverses its direction every 11 years. So it goes through a cycle where the field here diminishes and the field gets wrapped around itself by what they call differential rotation. The equator is moving westward faster than higher latitudes. And since the moon's gas, hot gas, a plasma, is a good electrical conductor, it turns out that it grabs magnetic lines of force and starts wrapping them around itself. So you start winding up the magnetic field near the surface like a ball of twine. And that, it takes about 5 years to get to a sunspot maximum when the field is very complicated from this uncomplicated field 5 years before. But the strength of the field when it's uncomplicated is easy to analyze, and at the last sunspot minimum, which was about 10 years ago, 80% of the created field, according to my theory. So that implies that the sun's reversals of magnetic field have chewed up a little bit of magnetic and electrical energy, but not very fast. So the energy loss would be about 0.15% per cycle. And then what happens after this is that the field suddenly changes direction. So these little bits of lines of force still coming out are now coming out in the opposite direction. The field has reversed, and then another 5.5 years, it now looks like this, except that the field is reversed. So sunspots, just for your information, the sunspots are produced by the tension in these magnetic lines of force. Think of them as rubber bands, and being pulled and twisted and tightened. So you think of a kinking rubber band, it's going to pop up and down in loops. And we know from astronomical measurements that the sunspots occur in pairs, and in one of the pair, the field is coming up out of the sunspot, and then it zooms down to the other of the pair and goes down. So that's what makes sunspots. So the sun is kind of fun, but it's complicated too. But anyhow, the bottom line is that the strength, when the sun's field is easy to analyze and uncomplicated, is close to what the theory predicted. So now this is probably something you should really pay attention to. The solar system data fit this wacky theory of mine, only with biblical conditions. So the time scale has to be short. Smaller bodies like the Earth and Mercury and the Moon and Mars need about 6,000 to 10,000 years of existence to explain their fields at present with this theory. And then the planets, big planets, or the planets and the sun must start as water. So it has have a biblical time scale and biblical materials. And why is that? Well, because the other stuff of which planets now exist, the nuclei have too little magnetic field. They're not a good thing to explain the present field with at all. Silicon, oxygen, calcium, iron. Sometime between the first day and the third day, God miraculously, I can't see a natural way for it to happen, took apart the nuclei of oxygen and did nuclear things with it and made them into other elements and then reassembled them into solid materials. But the solid materials now are not suitable for explaining the magnetic field. And then in the case of the sun, which is almost pure hydrogen, you would get too much field. You would get about 10 times more field than the sun now has. So it's, you've got to have just the mix of materials that you have in water. So that pretty strongly points to the biblical account being true. So just to briefly get you out of the solar system, the stars apparently all have magnetic fields. The Earth's field is about 1 Gauss. Ordinary stars like our sun, 10 Gauss. Magnetic stars are a small group of stars that have a really strong magnetic field, 1,000 Gauss. White dwarfs, which are stars that have collapsed down to a very small size, crunching the magnetic field with them, have about 10 million Gauss. Pulsars, which have crunched even more, have about 1 trillion Gauss. And there are a few beasts out there called magnetars that apparently have 100 trillion Gauss. They're the most magnetic object in the universe, much stronger than the magnetic fields we can get in the lab. So, but all of these appear to fit this creation model of origins of fields. Galaxies. Our galaxy is the Milky Way, and it looks a lot like this, a spiral galaxy. That's a sister galaxy right outside. And this is actual data, magnetic data that they take with their spectrographs and telescopes. And it plots the magnetic field. And the magnetic field they measure is between 1 and 10 millionths of a Gauss. Not much, but it's a really big field in size. And the lines appear to follow spiral arms, which have a number of interesting implications about how long those spiral arms can exist. But anyhow, they can fit the creation theory. There's one scenario for how the galaxies were created that gives you these numbers. But I'm not satisfied yet that that's the actual way God created them. So I'm still working on this. So this new book that's out there has much more. Earth's mysterious magnetism and that of other celestial orbs. So this is by me and an engineer friend of mine, Mark Despain, who he took all the technical articles that I had and squeezed them down and simplified the language and put in nice little explanation boxes and lots of gorgeous pictures. And he did a good job of writing. So it's at the level now where a college liberal arts student can understand it if he or she wants to spend some time in it. So I think this is a good resource for you. So that new book has more. It's available at creationresearch.org or creation.com, and you can get an ebook form of it at amazon.com. The other two sites, at least creationresearch.org, also has the ebook form of it, which is not expensive at all. So, bottom line, Let's see, okay, we've got time for at least 3 minutes worth of questions. A magnetic field show that God's handiwork in the heavens. So magnetic fields of planets and moons and asteroids and meteorites, suns, stars, pulsars, magnetars, and galaxies, and maybe the whole cosmos itself. We don't know yet. So, are we finished?
You go ahead and finish.
Okay, good. I'll take some questions.
Did they measure the magnetic field of Pluto?
Did they measure the magnetic field of Pluto? No, because they figured Pluto is an ice planet, and I think they're right. Ice, made of ice. It is a nice planet too, but, you know. But so they didn't even send a magnetometer out in their New Horizons space probe, and so we don't know if it really has a field or not. Yes, sir.
Yeah, you said that you were able to show degradation of magnetism in the crust rocks of Mars, and I think you said Mercury. How can you do that?
How do Mars' crustal rocks and Mercury's crustal rocks support my theory and not support their theories?
Right.
If I can rephrase your question. The answer is that even though the magnetic fields of those planets are either zero or very low, the crustal rocks were magnetized in a very strong field, which my theory says existed at the time of origin of those planets, 6 or so thousand years ago. So my theory, before they were ever visited, said the crustal rocks should record strong magnetic fields, and that's what they found.
But you said that it also showed it's the rapid degradation.
No.
Oh, I thought that's what you said.
Well, rapid degradation would result in the 6,000 year time scale from the time of origin to the measured field now. You just draw a line on the right kind of graph, and you get a half-life, and that half-life agrees with about the size of the planet's cores and what they're made of, probably. So, but maybe you're thinking of the reversals of the magnetic field. Okay. All right, next question.
Yes, sir, I just want to clarify the beginning of the model. So it sounds like your model is that a mass of water was created. A mass of water was created, and you started with the mass that's equivalent to the planet today, or Earth, for example. But Earth is more dense than water is today.
Yes.
So part of the model is that things kind of collapse. So I was kind of curious, where does the energy, and you talked about this magnetic field inflating in a fairly small period of time. So where does the energy come from that field? And I assume it also there's an electrical current that's ongoing today.
Yeah.
It must have started out in this water, but maybe there's also a transformation to other kind of nuclei instead of just water, which was the original substance.
Yes. Not sure what the question is exactly.
So my question is, what is the source of energy that sort of inflated the field? And do you have any ideas
That
about
inflated the field?
Well, you said that the field started shortly after this water sort of came into existence.
It started when the water came into existence, and the energy that of the magnetic field then was provided supernaturally by God when He provided the same energy that makes up the masses of the water.
Okay, so it came with.
It came and sold. That was the whole thought there. Is God evidently wants a lot of magnetic fields out there in the cosmos, and here's a handy way to make them. If you're going to go to the trouble and bother of creating 2 times 10 to the 50th power water molecules just for this planet, why not make them with all the proton spins pointing in one direction? Yeah.
So, what about the theory that that for Earth and everything, it's some magnetic field that is kept up due to when it was formed, many bodies, many celestial bodies were striking it, and thus the kinetic energy was converted to thermal energy and kept going on, and such that like the moon, there's a common theory that the chemical structure, so magnetism is probably due to the fact that when Earth was struck by a large celestial body, moon then came out of it and everything, it was well explained why it cooled down rapidly compared to the Earth and everything. Does the kinetic energy of sludge bodies, does that also account for the magnetic fields being maintained?
Oh, I think you're asking how do the dynamo theorists account for the startup of their field? Is that right?
Well, just want to see, does the kinetic theory with sludge bodies striking the planets, does that not hold up in comparison with your theory then?
No, the dynamo theory still is at sea as far as explaining the startup of a field. It has to start the field by processes they don't understand, and then it has to maintain that field for billions of years. And since the theory has failed for 99 years, the prospects don't look good. But, so this theory of origin of the planet, of our Earth, by all these collisions in this nebular hypothesis, the theory of formation of the solar system, since the dynamo theory doesn't work, then the nebular hypothesis theory suffers great doubt. In other words, the existence of a magnetic field on Earth now, when all the processes we know of cannot maintain the field for more than thousands of years, the fact that a field exists would have to exist for billions of years, and doesn't means that the billions of years are in doubt, and hence all the theories about the formation of the Earth billions of years ago are also in doubt.
So, what are the effects in the future of the decay on, for instance, Earth? Should we be worried? Is anyone else who has the dynamo theory, are they worried? Do they notice that decay?
Yes, they know about the decay. They say it's a reversal in progress, which is going extraordinarily fast for them. They say that most of the reversals in the past would have taken place over millions or hundreds of thousands of years, and this one would be taking place in only thousands of years. But they aren't worried about the effects of the magnetic field going away for the same reason I'm not, and that is that the magnetic field doesn't do all that much as far as what would happen if the magnetic field went to zero, which it wouldn't with this kind of constant percentage per year decay. It would never theoretically go to zero. It would get pretty small. But the magnetic field would, if it went away, the production of carbon-14 in the atmosphere would increase by 10%. We'd stop getting these beautiful aurora patterns at the north and south poles, but the radiation from cosmic rays wouldn't increase that much because of the thick blanket of air around the Earth. And then the time scale was too small for the cosmic rays to blow away any significant part of our atmosphere, which is the only thing they'd worry about. And they're not worried about that either because the time scale is short. So in other words, aside from a few birds and bacteria that use the field to navigate, nothing spectacular would happen.
Okay, we're going to have to cut it off. Let's get Dr. Humphreys applause.